I'm Claire Spillman from the Bureau of Meteorology. I'm based in Melbourne, land of the Kulin Nation. And just before I hand over to Alistair, slight change in our title, given the way our audience has expanded over the last 11 briefings. Originally, we had it as a fisheries climate briefing, but we've expanded it to marine since we've got folks from different agencies. FRDC is still our host, and so our primary focus, I guess, is fisheries and aquaculture, but just broadening it out and widening the circle of people who can use the info. So I will kick over to Alistair and you can take it from here.
Yeah, hello from Nipaluna, Hobart. In the last briefing, and this has been our typical pattern, is we do some kind of introduction to how the ocean works and how you can build your interpretation skills with working with forecasts and understanding ocean conditions. In the last briefing on the 14th of March, we covered how ocean temperatures are commonly measured from satellite and from in the ocean. And we looked at how cyclones can influence ocean temperatures. Cyclones are difficult to predict, much more than a day or a week in advance. And so we can't do a good job of them at several months ahead, but they do have an impact on breaking up heating. We looked at what some of the heat wave impacts were around the world in 23-24, not 23-34.
Sorry.
And this map here was an example of how much of the ocean was in marine heat wave conditions in the summer periods of that last summer period. And then we heard about the Sea Change Project, which is gathering information from around Australia and trying to look at how we can do a better job of integrating climate into decision-making amongst many marine users. When we talk about what's happening around Australia, we tend to do it in these briefings at about the scale of these boxes. We talk about what's happening in the GBR and Coral Sea region. We talk about what's happening in the Great Australia Bight. We're using that language because that's the resolution at which we generally are able to make reliable predictions several months into the future. But a whole lot of other processes influence what's happening at finer scales. And particularly, as I'll show you now, in against the coast, there can be very different processes going on that lead to quite different temperatures than just a marine heatwave forecast, for example, would lead you to think was going to happen. As with cyclones, these processes are very hard to forecast. The figure on the right-hand side shows all the different kinds of processes and how they influence things on different spatial and temporal scales. These diagrams are classically called Stommel diagrams. And you can see written on the plot here all kinds of words about oceanographic and atmospheric patterns that influence what we see in the ocean at different spatial and temporal scales. And marine heat waves, for example, tend to operate on time scales of about a year to a month or so at spatial scales of 10 to 1,000 kilometres. And they're influenced then by the different ocean processes under that. So now I flick to the left-hand side of the plot of this panel and say that's why we talk about climate change and its influence on the ocean, climate modes like ENSO, El Nino, Southern Oscillation, and horizontal flow of currents, because they're all bringing warmer water into different places. Last time we also talked about the subsurface structure of marine heat waves, because temperature can be hidden deeper in the ocean and then re-emerge at the surface. So today I wanted to talk about how you can get temperature variation in the ocean by the vertical movement of cooler water, and that's known as the upwelling process. And upwelling can be influenced by the wind, the tides, and the currents. And I've just got three quick examples. In the southern hemisphere, because of the rotation of the Earth, water is deflected to the left of the direction of motion. So if this is the Great Australia Bight and we have water flowing from the east to the west, we will see water deflected offshore. And that's what this picture on the right-hand side shows. When we get southeasterly winds blowing parallel to the coast, we get the vertical movement of water that brings up cooler water and gives us this temperature signal close to the coast. The area off Portland, for example, is known as one of the most intense upwelling areas in Australia. But they also get them on the on the western side of the peninsula as well. And around Australia, these can be produced by winds blowing parallel to the coast. Our heatwave forecasts do not pick up this fine-scale pattern, but you can imagine if you're aquaculture or fishing or tourism business or species of conservation.
Write back to all of the spammy vote for me people and say I voted 2 weeks ago.
Please, I think someone needs to.
Yeah, no political advertisements, please.
Thank you.
We're politically neutral in these presentations. These processes are very hard to predict in our forecasts. but you should pay attention to them because they'll influence what you see in your area of operation. So that's how wind might produce upwelling. The second example I've got is from tidal mixing. And tidal mixing, for example, occurs along the Great Barrier Reef. So the slide on the left-hand side shows you areas in very dark blue, which are often cooler than usual. And these might be refuges today and into the future against warming. On the right-hand series of plots, it shows you how you get that injection of cold water by the fact that tides mix. In the first panel, you've got water flowing down the coastline. And as the tides go in and out, in the second plot down there, the tides can kind of draw up a little lens of cold water onto the shallower area. And then in the bottom plot there, it shows you as the tides kind of mix and so on, you'll see that cold water give you a surface signal. And that's what's happening in parts of the Great Barrier Reef. And so it's a subject of current research as to whether or not these cooling areas will persist into the future, because we might want to do special things on the Great Barrier Reef in those areas. And you can have this tidal mixing around Australia in different places. Finally, the last example is when we can have this just because of the motion of currents. And so my example is from the New South Wales coastline here, which shows on the left-hand side an eddy moving water south parallel to the Sydney coastline. And you've got cooler water in against the coast because water is moving south, it's deflected with the Coriolis force to the left offshore, and you can fill that gap with colder water coming up from the surface. In the right-hand side plot, you can see that that shows up as very red areas indicating high chlorophyll. And so that's also how we bring nutrients to the surface by this upwelling. So these are important processes to pay attention to. And in the following slide, we suggest that you look at things like the IMOS ocean current information to look at what's happening very close to the coast and at finer scales than the broad forecast that we can provide will show you. Claire.
Thanks, Alistair. All right, so I will now go through what the recent ocean conditions have been around the country and then step through the forecast for May through to July. So hopefully you can't hear the roadworks outside our window. I'll just talk loudly over it. All right, so recent conditions, given it's only the 2nd of May, we don't have the data yet for April, but this is the information from March. It just gives a bit of a picture of what happened around the country during that month. And so the dark orange colour is highest on record since 1900 for March. So in the continuing story that we've had for the bulk of this series, it's been very warm on the west coast. That is, this light orange colour here is in the top 10% of March values in the last 125 years. And then this orange area here off Ningaloo on the northwest shelf, highest on record. The other area that we've talked about repeatedly this summer has been the Bight. So for much of the Great Australian Bight, it has also been the highest on record for March. Typically for Australian waters, March is not the warmest time of the year, with the exception of WA. So WA tends to have a warm peak in December and another warm peak in March, April. So these warm conditions, on top of what is already a warm month, is leading to some of the impacts that Alistair will talk through later on in our briefing. If we look at it in context for the whole of Australia, you can see here that March for this whole region here is the 2nd warmest on record for the whole area. So it's very warm conditions. They've persisted over the whole summer, and that is also setting up for what we will see going into winter. So if we take a step back and look at what's going on in the global oceans, you can see these warm conditions. This is for the last week, roughly the last week. Anything pink is warmer than normal. So these sort of dark pink colours are 2 to 3 degrees warmer than normal. That's pretty warm. So all of WA and through the Bight, the same 2 areas that we've seen persistent heat. Also parts of New South Wales and around Tassie. Tasman Sea is pretty warm as well, and there's also warmth in the Coral Sea. Out in the Eastern Pacific, areas that are white are about what you'd expect for this time of year. Anywhere that's blue, and there's really not much of that on here, is cooler than you'd expect. So I'll step through the El Nino, La Nina forecast in a few slides' time, but what you would see if there was an event underway would be a strong signal here in the Eastern Pacific. We're not seeing that. That's because we're in neutral conditions. Looking at marine heat wave conditions, and I'll also show a slide later on where we can see how it's evolved over the summer. Same pattern we've been looking at in the last few briefings. Warm marine heat wave conditions on the Northwest Shelf. This is that top 10%. This is for last week or so, and through the Bight, also through Bass Strait and parts of the Coral Sea. This is based on the surface, so this is the top 1 metre of the water column. And if you think back to last briefing where we talked about that heat at depth, this is what we're showing here. So this is heat content. So this is how much heat is in the water column down to 300 metres. Anywhere that's red is considerably warmer than you would normally expect this time of year. And the reason we look at it is because if the heat is down in the water column, it's going to take more than a couple of windy days or a strong sea breeze to really mix that heat out. So we may lose the signal at the surface because it's a nice stiff breeze that's mixing it down a little. But when you look below that first, metre or so, that heat is still sitting there, and that's hard to shift. That could be recharging the surface. So all that heat we're seeing on the WA coast is very warm at depth as well at the moment. Is warm in through the Bight, and then you can see some of the warm eddies here off the southeast coast as well. Warm and cool ones there. Okay, so this slide, don't worry about the dates too much. All I've done here is taken week by week by week. And what I was put these in here to show is just how persistent, particularly the Northwest Shelf has been over summer. So we're starting mid-September here, just flicking through each week, going across. So the top row here is sort of mid-September to mid-October, then the next mid-October to November, and then through to the end of the year. Anywhere that's yellow is marine heat wave conditions. Anywhere that's orange is strong marine heat wave conditions or above. So you can see the marine heat wave we've been talking about in WA has been there since September. So if you step forward, there's also marine heat wave conditions through the Bight, not as pronounced and not as an extensive an area. But I thought it was useful to have a bit of a retrospective. So it's not only the heat that we're looking at right now, but how long has it been there? And that will also be related to the kinds of impacts that we see. So chronic stress over the summer for those particular regions. So if we just follow your eye through, going through each row, you can see this heat here on the Northwest Shelf has pretty much hung around for the whole, we've got 16 weeks on here, coming through into January of this year. Heat in the Bight as well, and you can also see that we started to see marine heat wave conditions off New South Wales and in the Coral Sea as well, starting to ramp up in December, January. We continue that story, so pick up where we left off straight through January. You can really see the marine heat wave amping up on the Northwest Shelf. These are very high. You don't see these kind of dark colours very often. So we've got extensive, strong and severe marine heat wave conditions through WA. Bight still's just cooking away quietly. WA is getting all the attention because it is pretty extreme there. But if you have a look at the Bight through each of these weeks, it has been consistently warm throughout the summer. The East Coast, not so much. We saw a bit of heat early on in the summer, particularly up in the northern Coral Sea, but that has pretty much dissipated as we've stepped through to March. Heat still hanging around in WA, still in the Bight. And even as we step through into April, there's a bit more warmth up here in the northern Coral Sea going into April, but this is not necessarily our peak time of concern for coral bleaching. So it may affect other industries, and if you are seeing impacts, we'd be keen to hear about them. But that WA and South Australia is a continuing story through up till last week. So that's the sort of the summer in summary in terms of marine heat wave conditions and what we've seen. So how did the forecast that we looked at in mid-March shape up? So we've got the top 3 here that I presented. So we've got week 2 and 3 of March, and then end of March going into April, and then for all of April. This is sea surface temperature anomalies, so how much warmer or cooler than it is than normal, top 1 metre. And in the bottom row, this is what we observed. So this is measured by satellite, and you can see that the model's done a pretty good job. It actually hasn't changed a whole lot. Same areas, WA, South Australia, parts of New South Wales in March. However, we did start to see some cooling here through the northern part. Could have been due to cyclone activity up through here. I can't remember off the top of my head what was happening there at the end of March. But for everywhere else, you can see those consistently warm conditions. And as Alistair mentioned, if this is TC activity here that we see some cooling at the surface, the model can't capture that. Again, you see that persist through to April. So warm everywhere around the coast. The model overestimated what was happening up here in the Kimberleys, but that may be due to some monsoonal activity or cyclone. Looking at marine heat wave, so the extreme part of that signal of the sea surface temperatures. Again, very similar pattern. Because this forecast is built on those sea surface temperatures, you're going to see a similar theme. So looking through from the rest of March through into April, you can see the model has predicted, it actually predicted marine heat wave conditions up off Kimberley, which we didn't actually see. But we did on the Northwest Shelf and down the coast of WA and through the Bight. And the model captured that, as well as these areas of higher or stronger marine heat wave, I should say. Stepping through to April, consistent. It was actually warmer on the Northwest Shelf than the model captured, but it still noted that it was marine heat wave conditions. And then heading into April, you can see some of the marine heat wave conditions resolved here, heading out offshore from the Kimberleys. And we can see that in the observations as well. And then also marine heat wave conditions were predicted down the coast of WA and through the Bight. There were warmer conditions in the Coral Sea than the model predicted. It predicted some closer to shore than we actually saw. Oh, sorry, closer to shore and not offshore, whereas actually warm across the Coral Sea. But overall, the model's done a pretty good job of predicting what was happening for those 6 weeks. All right, so stepping forward, so these forecasts here are going for May through to July, so into our winter. Global outlook. So this is the forecast for May to July as an average for those 3 months. So anywhere that you see that is pink is going to be warmer on average for that period. So you can see here, it is just a consistent pattern. So WA through to the Bight. Bearing in mind this is relative to winter conditions. So if you have operations or there's particular species that are sensitive to wintertime temperatures or parts of their life cycle, this might be where you want to pay attention. Less of a risk for things like coral bleaching, which are using absolute temperatures, or are related to absolute temperatures, so your summertime ones. But still, the model is indicating we're up around 2 degrees warmer than normal through into winter on the WA coast and through the Bight, and also parts of the Tasman Sea. If we look at ENSO, so this is El Nino, La Nina. At the moment, the models from the Bureau is in line with the other international models that we look at, saying neutral conditions. So it's neither La Nina or El Nino, through till at least September. So what you can see here is this is a box out in the Pacific where we look at the sea surface temperatures and how warm they are. All these grey lines are the model runs. The majority of the grey lines are here in this white area of the map, of the plot, sorry, which is saying neutral conditions. There are some going into El Nino territory, which means there is a small probability of an El Nino event developing. The forecasts that are produced in May for late towards the end of the year have low accuracy. It's hard to predict these kind of conditions for, say, November, December from May. So we'd keep an eye on these forecasts. The IOD, so the Indian Ocean Dipole, for those on the west coast, is also predicted to remain neutral. Just here down on the right-hand side, don't need to look at the details, but it's just showing these grey boxes are all falling in that white neutral area. So they are the other models that the Bureau looks at, just to make sure that our model is in line with what other prediction systems are showing. Okay, so rainfall and air temperatures, so these are important. They're another piece of the picture, particularly if you operate inshore or have a coastal operation. So the rainfall outlook for most of the country is either normal or drier than normal. So this This map on the left is looking at the chance of exceeding median rainfall for the season, May to July. So there's a pretty low chance it's going to be more than above median rainfall. Southwest WA. So folks putting crops in, they're probably not very excited about that that forecast, and also down across northern Australia and down the east coast. If we want to look at the extremes, so on the right-hand side, this is just showing the chance of it being unusually low. So if you think unusually low rainfall, that's low cloud, clearer days. So that's one of the reasons we look at it. And you can see for Southwest WA, parts of northern Australia and parts of the coast, it's quite a high, well, it's an increased chance, I should say, of unusually low rainfall. Coupled that with a warmer than normal late autumn and going into winter, so May, July season for air temperature. So that's obviously related to what's going on in the ocean. The chance of exceeding median daily daily temperature, so your air temperature, is very high. And then the chance of it being unusually high, so top 20% of your air temperature you'd see, is very high, particularly for Queensland. And this is also reflecting those warm ocean temperatures that we're seeing. So that parts of WA, no surprise, it's going to be warmer than usual. And also through parts of the Bight and through Victoria. Okay, so getting into the water. So for the next 2 fortnights, so this is from, these forecasts are from a couple of days ago, so through for the next week and a half, and then for the middle 2 weeks of May. So similar pattern, we're seeing that those cooler anomalies up here off Kimberleys that we were seeing in the observations, they're hanging around for the next few weeks, but very similar story. So warm conditions, so we've got anomalies of maybe up to 2.5 degrees warmer than what you'd normally expect for this fortnight from the northwest shelf down. So down past Ningaloo, Shark Bay, round the Capes and through into the Bight. The highest anomalies are around here, around sort of past maybe Geraldton, round past the Capes in WA. It's still warm through the Bight, but maybe not as high as what we've been seeing. However, they're warm enough to exceed the marine heatwave threshold. So marine heatwave conditions from Ningaloo, Northwest Shelf, down around the Cape, through the Bight and into Bass Strait, and extending further offshore than we actually had seen in the last few months in the south. So over here on the left-hand corner is our model skill. So we go back and look at the last 40 years of forecasts and say, how well does the model do when it's trying to predict temperatures this far out for this time of year? Essentially, anywhere that's green or dark green, the model does a good job. So we've got high skill. We're not trying to predict 6 months out, we're trying to predict a month out. So the skill is good. So we've got reasonable confidence in the forecasts. Stepping through now to June. So our skill, you can see here in this bottom map here, has dropped off because we're trying to predict a bit further out. These white patches here of New South Wales are due to that eddy activity. It's really hard to get the eddies in exactly the right spot, and that's why you see these sort of white patches where the model doesn't do a great job. Similar pattern. So we've got SST anomalies at the top here, continuing to be warm. For WA, around Exmouth, Shark Bay and around the Cape. We've got anomalies again of 2 to 2.5 degrees warmer than you'd expect for June. So again, that's relative to your wintertime temperatures. So I think it'll be interesting to see what the impact of that long-term chronic stress has been on those fisheries and ecosystems in the area, but also what it means for a warm winter going into next summer. If we get into the water and we look down off the shelf, that heat is at depth as well. So all this this red colour you can see of Northwest Shelf. There's a few blue and red, dark red patches here, which are eddies. It's quite warm still at depth and also through to the Bight as well. Looking at that in terms of marine heatwave, again, just at the surface, these colours around on this plot show how many of those model runs, how many of those grey lines were in marine heatwave, above the marine heatwave threshold. Dark green, 80 to 100% of those forecasts were. So continuing story for June, Bight and central southern WA marine heatwave conditions have been predicted. Strong marine heatwave conditions for Ningaloo, Shark Bay, heading down past Perth and parts of the Bight. Very similar story. I sound like a broken record for July as well. So same areas. The anomalies do drop off slightly. So they're not quite as high as they were. So that indicates some cooling. Our model still does drop off because we're predicting even further out now, but still marine heatwave conditions for bulk of those two areas, so WA and South Coast. And it is also warm at depth. So that heat is just sitting there. Okay, I will hand over now to Alistair to do a bit of a retrospective of the summer and some of the impacts, and also a bit of a call out to the audience for feedback for us as well.
It's been unusual to see both the West Coast and the South Coast with such strong heating this year. The Great Australia Bight has escaped these kind of conditions since we've been working on this for the past 4 or 5 years in doing this forecasting development, but you've definitely seen it come into your waters this year. This is a summary of what we know has happened around the country this year. And I'll start off the northeast of Australia on the Great Barrier Reef, where bleaching has been reported from the northern zones of the Great Barrier Reef. Coming around the top of Australia into that strong warming on the northwest coast, a fish kill, bleaching, and record and reports of out-of-range species are coming in now. And we'd expect with that warming being persistent that, as Claire said, the bleaching and the out-of-range species things to continue over the next few months. In South Australia, there's been a plankton bloom and fish kills that are kind of indirect effects of the warming. And so I don't have enough knowledge to know whether they're a direct effect of the marine heat wave or it's a coincidence. So I know there are experts in South Australia looking at that association now, but it's at least impacts that have occurred at the same time as warm conditions have been noted in the area. In Tasmania, earlier in the season, there was a salp bloom, which was followed by a noctiluca bloom, which is the bioluminescent plankton. Then there was a jellyfish outbreak, and then some penguin reports of penguins having declining food resources and not very good foraging success that impacted on breeding success. Maybe that was a bit of a cascade of effects, and the order that they appeared is in that order. So the salps suck out the nutrients. The noctiluca is then able to bloom into an environment relatively free of predators. Jellyfish do very well in low nutrient environments, and then penguins obviously need food, and perhaps it was absent. But again, all of this is a bit circumstantial at this early stage. But you can see these impacts occurring right around Australia with the exception of southern Queensland and New South Wales. We were generally, though, on the receiving end. And so how could we have better used the information from forecasts? On the left-hand side there, these are the national briefings you attend here, are one way of getting the information. And then there are a variety of state and regional efforts that provide more detailed information. This year, I'm not aware of as many sectoral briefings going on. Coral reefs in both northeast and northwest Australia got their communities together, but I don't know as much happened with industry-specific group briefings or industry working groups. And so there might have been a more opportunity that could have taken to be more proactive in our responses. And our ability to be proactive is, in my view, related to these orange factors on the right-hand side. Can you actually manipulate your system to avoid the worst of extreme events? Does the regulatory environment permit you to change, for example, where your fishing operation, your tourism business, or your conservation activity takes place? If you're responding to market forces, you may feel that you're trapped and you're having to do your harvesting or supply things in the same way, regardless of the heat. And then as we work around through 4, 5, 6, and 7, all of those influence your ability to do something. But as Claire and I and our teams have looked at what those impacts were, in general, it's the ability to manipulate the system that seems the strongest influence on whether you can be proactive. Please use this off-season to think about how you can manipulate your system if you had early warning. As a conservation manager, as a restoration practitioner, as a commercial fisher, as a recreational fisher, as an aquaculture business, and so on. If you get information about the future, what can you do ahead of time to reduce your impact? We try and guide you through that in these briefings with discussion of the phases of marine heat waves and extreme events. And I'd just remind you that at the moment we're in most of Australia on the east coast and the Tasmanian region in the recovery event. Western Australia and South Australia are still in phase 3. They're still during marine heat wave events. But as we approach next summer, everyone will shift probably to the first phase again, where it's really important to look at baseline data, maybe look at where your upwelling areas are and are they likely to provide any refuge? And again, look at your vulnerable industries, ecosystem and populations. And if you're able to use this low stress period over the winter and approaching next summer to prepare for taking action, I think you'll find yourself less on the receiving end and more on the proactive end. I really hope Australia is able to take advantage of these early warnings. Jamie, I hope we have a poll set up shortly, and depending on which mode you've used, various audience members are able to respond to these questions or not. But the thing that helps Claire and I and our teams tune them is how is the information we're delivering helping you with your decision making in the first question? The second one, are you doing anything differently? Are they still going to have value for you in the future? And then in particular, topics of interest there. So I will pause there, Jamie, and can you talk to the poll that will come up on the screen?